Here we have 4 containers, 2 of them for copper chloride solutions, the third for distilled water, and the fourth for tap water. The left bag contains dilute copper chloride solution. The right one contains concentrated copper chloride solution, and the middle one contains distilled water. Let us open the containers. Cut open the bag with the dilute solution and transfer its contents to the appropriate container. Repeat the procedure for the other bags. Now let us examine the conductivity apparatus. We have a bulb, which must be screwed in tightly to ensure that it works. There is also a spare bulb and a battery. There are 2 wires extending towards 2 electrodes. The wires are connected to the 2 electrodes in series. Use sandpaper to polish the electrodes. Now, replace the cover. The alternative conductivity device is also equipped with an ammeter. Inside this device, we also have a bulb, a battery, and a spare bulb. Let us replace the cover and polish the electrodes with sandpaper. The purpose of this experiment is to test the conductivity of each solution. Place both electrodes into the distilled water and observe what happens to the bulb. Repeat the procedure with the tap water. Next, introduce the device into the dilute solution of copper chloride and compare the intensity of the light to when the electrodes were immersed into the container with concentrated copper chloride solution. If you have the device with an ammeter, you will be able to see more details. Note that the bulb does not light up and the ammeter needle does not move in the case of distilled water. With the tap water, the bulb does not light up, but the ammeter does measure some current. Since the composition of tap water varies from place to place, it is important to note that the reading will vary accordingly. In the low concentration copper chloride solution, the bulb lights up but at a very weak intensity, and the ammeter reading is approximately 100 milliamperes. In the concentrated copper chloride solution, the light intensity is considerably higher, and the reading is above 160 milliamperes. We no longer need the 2 copper chloride solutions and the distilled water, so let us replace their covers and put them aside for future use. The next experiment is conducted using tap water. Here we have a container with tap water, salt, sugar, and a stirring rod. First, we will measure the conductivity of tap water. Observe that the bulb does not light up. Next, let us mix in the sugar and measure the conductivity. Observe that there is no change from the tap water. Next, we shall add a small amount of salt into the sugar solution and stir it vigorously. Observe the light in the conductivity device. Alternatively, we can use fresh tap water and dissolve a small amount of salt into it. Add more salt and once again observe the intensity of the light. We shall repeat the last experiment using the other conductivity device. Measure the conductivity of tap water. Add the sugar, stir, and observe the conductivity now. The bulb does not light up and the reading is the same as with the tap water. Next, add a few grains of salt. Mix well and examine the conductivity. There is a very weak light from the bulb, and the reading approaches the halfway mark on the scale. Now, add more salt, mix, and examine the conductivity. The bulb shines brighter, and the reading is close to the 3/4 mark on the scale.